afternoon.
Good afternoon, ma'am.
Yeah. Shall we start the session? We'll see how interview questions are asking in the written test and all. The basic Verilog questions and also different topics will revise now. Okay, the interview questions. Okay. So first question is, can you tell me what is the answer for this? What does Moore law specifies? Just tell the answer,
Trans
whoever know. Yeah.
Number of trans will increase exponential with time, ma'am.
Okay. If number of transistor increases, power consumption in VLSI will increase and clock speed will increase. Tell. If this condition satisfy, both these conditions satisfies.
No, ma'am.
No. Right. Maybe speed of clock or speed of chip increases, but power consumption will not increase. Okay. So what more specify means the number of transistors in the VLSI chip will increase exponentially, double for every 2 years. Okay. And the size of the transistor will be reduced to half. Okay. That's what Moore law said. Okay. Right. Is there any doubts?
No,
No,
ma'am.
ma'am.
Okay, coming to the second question. Which of the following example has structural design representation? How many type of representations we have in Verilog?
3 types, ma'am.
3, ma'am.
Okay, can you tell?
Behavioral,
Okay,
data flow, and gate level, ma'am.
gate level. Okay, and also switch level. Okay, so structural level means what? Structural design representation means?
Designed by using the structure of that component.
Yes, sir.
Use
Both there
hardware.
will be, yeah, there will be functional blocks and there will be gates and flip-flops. Okay, there will be no truth table is nothing but behavioral modeling. So first two options are correct, right? And coming to the third question, if w, x, y, z are reg, integer, wire variables respectively, each of the size is 8-bit size, 7 down to 0, which of the following is or allowed inside a procedural block? First of all, what is mean by procedural?
Blocking and non-blocking, ma'am.
Blocking and
Initial and
non-blocking.
always block.
Initial and always blocks are procedural assignments, right? What are continuous assignments?
Blocking and non-blocking.
No.
Assign, ma'am.
Assign is the continuous assignment, right? In procedural blocks, we have initial and always block. Okay. Whenever we are using always block, there, if there are multiple number of statements, there we will use blocking and non-blocking assignment. Okay. Z is equal to W plus X, Y equal to W plus Z, Z equal to something, X equal to something, right? W is reg here, X is reg, Y is integer, and Z is wire. So we are using in the procedural blocks these statements. Okay, if we use in the procedural block, which are allowed. Did you remember conditions for procedural block when we use the initial, when we use the always block, we discussed the conditions like all RHS side, LHS side, which data type should use. Can you repeat those conditions? Anyone?
LHS use reg, ma'am.
LHS side should use only reg data type. Reg data type means register data type. Okay, register data types are nothing but what are registered data types? Can you tell? What are registered data types?
Means time and real
Mm,
integers.
mm, real integer. Okay, and reg data type. Okay, reg is the synthesizable, these are non-synthesizable, so these are the registered data type. Okay, then RHS side, which can be used when we use procedural.
Ma'am, we can use either net data type or variable data type in your HSI, ma'am.
We can use either net data type or registered data type. Can you tell me what are different net data types we have?
Wire, ma'am.
Wire and W or W and these are the different type of net data types, right? Now, according to our question, can you tell me which option is correct?
Option D is correct, ma'am.
Option B. Okay, next.
D, ma'am.
D. D is X reg data type. Okay, and Z means wire data type we
Wire
can't
data type.
use. Y means integer data type. Integer also we can use in the procedural assignment, right?
Yes, ma'am.
Here Z also wire, so we can't use. So option B, option D correct, right? X and Y. Okay, clear? Have any doubts, anyone?
No, ma'am.
Okay. Next, coming to the fourth question. Consider the following Verilog snippet. Suppose A and B are declared with a 6-bit data type C and assign C equal to X or A. Okay. So if the values A and B are given, A is 10011, B is 01110. What will be the value of A of 3 down to 1, comma 2 of C, comma B of something? Okay, so which type of operator it is? Which type of operator?
Concatenation operation.
Concatenation operator, right? Now, can you tell me the output here? Which option is correct?
Okay, there is a 3 down to 1.
Okay.
Next, C 2. C is the C equal to cap of A. That means
XOR of A.
1.
Okay.
And B is 2 down to 0.
B is 2 down to 0. 110. C is XOR
0.
of A.
A.
Okay. So B is the correct answer, right? Is there any doubts? Okay. Next question. Module has given with input current state and output flag in always block with respect to the current state. We have taken the case. Okay. What is the current state size? 2-bit size. 2-bit size means 4 different values it will be generated, 4 combinations, right?
Yes, ma'am.
In 4 combinations, only 2 combinations assigned with the value, and for 3 total 3 combinations assigned a value, and 1 combination didn't assign any value, right? In that case, what happens? Suppose this is a combinational logic circuit. In that case, what happens? If any default statement is not there, or if we don't write a else statement, if any program is like incomplete, what happens?
Ma'am, latch will be generated, but which value is not assigned, that will be un, don't care state, ma'am.
Okay, first of all, latch will be generated, okay, which is not useful. It is a unwanted. Okay, if latch generates in a combinational logic circuit, what happens? The whole circuit will be damaged, like, because it is a unwanted functionality is adding into the combinational logic circuit. Okay, so always we need to take care without any latch. That means we need to put some default statements, right? So which example, like which option is correct here? Which option is correct here?
C, ma'am.
C. Why C? If the synthesizer supports adder, subtractor, blocks, a combinational logic circuit will be generated. Here combinational logic circuit will be generate. See here.
But it is unused, ma'am.
Okay. Unused means
Like bad latch. It is not
bad latch will be generated. Latch is nothing but a storage element, right? Storage element in the sense it is a sequential logic circuit with a storage element will be generated, right?
Yes,
Will it
ma'am.
generate a pure combinational logic circuit?
No, ma'am.
No. So a storage element will be generated. Okay, that's why option B is correct. Okay, did you understood everyone? Everyone got
ma'am.
the point remaining.
Yes, ma'am.
Tell for seventh question. For the following Verilog code, what will be the number of bits? Like a sum we have taken as deduced during the synthesis. Okay, suppose here two inputs are taken. Input 1, input 2 with the size of 7 bit. Okay, and temporary variable with the size of 8 bit. And a integer variable. Sum is equal to into 1 in 1 plus in 2 plus temporary variable. Then what will be the size of a sum here?
8 bits, ma'am.
8 bit. How? How 8 bit?
While adding of 8 bits, the final output is also 8 bits, no, ma'am.
Okay, but here, okay, in 1, in 2 is there 6, 7 bit size or 7 bit size. Okay, if we add 7 bit size, then what happens? 1 bit extra will get, right? In addition. So here 8 bits. Okay, here also 8 bit size, 8 bit size. If you add two 8 bit variables, then what will be the sum? 1 bit will get extra, right? Whatever it is, carry or whatever.
9 bits, ma'am.
9 bit. So here sum you need to declare as a 9 bit. Okay. Did you got the clarity, everyone?
Yes, ma'am.
Okay. If you have any doubts anywhere, you just ask. Next, eighth question. What does the statement like assign Z is equal to A XOR B or C XOR D? Can you signify this? Whether it is like a structural description or gate level description or behavioral description?
Behavioral description.
It is a behavioral description, right? So here we are using the assign. Assign is nothing but a data flow. Okay, in the data flow, we will just tell the behavior of the equation. Okay, it won't give any structural description or any gate level description. Okay, data flow is nothing but it is a expression taken from the behavior of the truth table. Okay, any doubts?
No, ma'am.
Okay, next question 9. Which of the following constructs will be generating a multiplexer where w, x, y are the variables? So here if you see, assign w equal to a x of y equal to w, and w equal to conditional operator, and w equal to x and y. So which of the following expression will generate a multiplexer? We already did programming also.
C.
C. Okay. How? Can you
Using
explain?
ternary operator. Mux has a selection line and 2 inputs, 1 output, ma'am.
Okay.
If it selects A1, then the output is
Mm. If you take 2 by 1 multiplexer, it has 2 inputs, 1 selection line, 1 output. But here only 3 variables are given. Okay, one is output. So output is suppose in the case, in this case, output is a W, S is the selection line, Y is the input. Suppose like that, you just consider and tell me here.
X is an selection line, ma'am.
Tell.
When selection line is 1, um,
Okay.
Y is printed and else
Mm.
Y not is printed, ma'am. Tilt Y.
Mm. So for a multiplexer, here y is the input. Suppose here y0, y1. If you consider 2-bit size, x is the selection line and w is the output. Okay, if x is 0, y0 or y will be get assigned to the w, and if x is 1, y1 or not y will be assigned to the w. Okay, that is the case. And also, is there any other option which acts as a multiplexer? This array model. What about this? We already did programming.
Data
yes,
into
ma'am.
selection line, ma'am.
Mm. So how it will be work as a multiplexer?
W is an output and X is data, Y is selection line, ma'am.
So here y is selection line, x is a data. X will be any bit size, x0 or x1 or x2, x3, x32 bit size or 64 bit size, whatever. Okay, y is the selection. Y is also any bit we can take, either 3 bit or 4 bit, whatever. Okay, so if y is 0, x of 0 will be get assigned to the W output. If selection line is 4, x of 4, that means whatever the data is there in the fourth line, that data is get assigned to the output. Okay, right? So this equation also work as a multiplexer. Okay, no limited size. You can take any bit size. Okay. Have any doubts here? Okay. Next, coming to the 10th question. What does the following code snippet implement? Can you tell me? Either it is a 1-bit latch or a 2-bit register or two NOR gates connected in cascade or 2-bit comparator. Output.
NOR gets connected in cascading.
NOR gates connected in the cascade. Here C NOR. So C and B NOR with D. Okay, here A D. So here D and NOR gate C. So two NOT gates connected in the cascade. This C is nothing but here. Okay, so option C is the correct answer. Okay, and here the following code segment generates a periodic clock with a time period initial clock equal to 1, always hash 10 delay, clock equal to not clock. You already know how to generate the clock using the always block, repeat and forever, right? So what is the time period of clock here?
10, ma'am.
10? How? How 10?
After 10 seconds, it nor goes to not
It
clock,
should
ma'am.
be
What
0,
is mean by
ma'am.
time period? First of all, what is mean by time period?
For generating one clock cycle, ma'am.
For generating one clock cycle. One clock cycle means
Completely
completed. That means on time plus off time.
off time.
Right. So this hash 10 is for what? Off
20
time.
time period, ma'am.
So this hash time is for only half cycle, either on or off. So on plus off equal to 20 here. 20 time units it will be taken to generate one clock cycle. Okay. So 20 is the correct answer. Okay. Have any doubts?
No, ma'am.
Okay. Next question. If clock and clear are two inputs of a counter module, which of the following event expression must be used if we want to implement asynchronous clear? Okay, assuming clear is a active low and active high edge of the clock we are taking. You already know what are the asynchronous signals we have coming to the counters. There are two asynchronous signals, right? Preset and clear. Whenever preset is high, it will be the output, the trigger will get high. If clear is high, the trigger will get 0. Okay, whenever clear is high, automatically the output will go to clear state. Okay. So, can you tell me how you can implement here within the always block?
Always positive clock or negative clear, ma'am.
Yes, always at the rate of positive clock or negate clear because it is a active low. Okay, this is how we can specify a asynchronous signals in the always block. Okay, so whenever clock is with respect to the positive edge of the clock, this signal will also generate it. Okay, but asynchronously. Okay, with the respect of clock, whenever clear is high, the output will trigger. Okay, clear?
Yes, ma'am.
Okay, next question. Which of the following is true for repeat loop? You know repeat we already used, right? Can you tell me?
It can be used to iterate a block until a specified condition is true.
Okay, what is the syntax of repeat? Can you tell me?
Ma'am, this is none of these, ma'am.
None of these. Okay, can you explain why?
Uh, iterate a block until specified condition is true, that is on while loop.
Okay, good.
Repeat means executes for a fixed number of times, ma'am.
Okay.
It In syntax, what is the which is constant number we have given, that number of times it repeats, ma'am.
Okay. So that's why none of these, right?
Yes, ma'am.
Okay, correct. Okay, if you see here, it iterate a block until a specified condition is true. Okay, but in repeat block, we won't give any conditions. Okay, we just give n value. Okay, some number. Okay, how many times it need to repeat, just that number we will give. Okay, but we won't specify any condition. That's why it's wrong. Next, it repeat indefinitely. It iterates indefinitely. Wrong. It iterates exactly 2 times. Wrong. Okay, so none of these. Okay, clear? Have any doubts?
Yes, ma'am.
Okay. Now, what does the construct hash 5 indicate in the simulation?
Yeah, ma'am. It specifies that unit of delay in 5 nanoseconds.
Okay. So it specifies that unit of delay only. Okay, of 5 nanoseconds. Okay, and it specifies after unit, after execution, or before execution. All the things depends upon intra assignment delay, inter assignment delay. Those are different. Okay, but here it specifies just unit of delay. Okay, whatever is nanoseconds or picoseconds, whatever. Okay, clear?
Yes, ma'am.
Okay, next coming to the 15th question. For the following segment, the final value of variable d will be. What is the value of d here? Before that, we'll see one by one statement. A is given as 25, B is equal to 12, C equal to 5, D equal to 17, right? First of all, what is this representation?
Blocking, ma'am.
Blocking assignment, right? Okay, now tell what is A value here? B plus C means
17, ma'am.
B plus C is 17. Okay. Then B equal to A minus 15.
Delays are added, ma'am.
Delays are added. Here we didn't given any delay. Just statement wise we have given expressions only. Blocking assignment is nothing but previous value will be retained to the next statement.
Yes.
Then what is the A here?
E equals to 2, ma'am.
17. B
B equal to 2. Okay. Next, what is the C here? A value, how much?
34.
A value 17, ma'am.
A value 17, D value
17.
17. Then output
34, ma'am.
34. Okay. Next, what is the D?
D is 34, ma'am.
Next statement.
5 plus
51. Okay. C is 34, D 17. So final value D is 51. Right? It is the blocking assignment. Suppose if you are taking the non-blocking assignment, what is the output? Next question. What is the value of A here?
$17, ma'am.
Okay. 17. B
10, ma'am.
10. Okay. C
42.
42. Okay. D
22, ma'am.
22. So D value is 22. Okay. Clear? You already know why we are using the delays here, intra and inter delays for blocking and non-blocking. Okay. So clear? Have any doubts?
No, ma'am.
Okay. Next, 17th question. Suppose what will be the following code generate on synthesis, assuming that the four variables like a data 0, data 1, data 2, data 3, okay, map into the four latches or flip-flops. Okay, so whether it will generate a flip-flop or a latch.
Flip-flop.
Flip-flop. Okay. Tell, suppose data 3 is assigned, data in is assigned to data 3. Suppose here input, here 3 is there. Okay. And here 3 is assigned to data 2. The 3 is assigned to 2 here. Again, the 2 is assigned to 1. From the 1, output is getting data 0. Okay. If you see here, all are blocking assignment. Okay. Blocking assignment for which circuits we will use, for sequential or combinational?
Combinational, ma'am.
Combinational circuits, right? So here will it generate any register like that? You can select any four options. Because it is the blocking assignment, it doesn't generate any register here. Okay, just all the flip-flops are cascaded in a manner. Okay, so answer A is correct. 4 D flip-flops all fed with a D input. Okay, just cascaded one by one. Okay, so it doesn't generate any shift register here. Okay, but in place of blocking assignment, if you taken like this non-blocking assignment, obviously it will generate a 4-bit shift register, right? Because here we are using the non-blocking assignment. Okay, and also the assignment will be different. If you use non-blocking assignment, we can avoid the race conditions also, because the data variables will doesn't retain its previous value. Okay, so it will be generated a 4-bit shift register, right? That is the difference. Clear?
Yes, ma'am.
Okay. Next question. Which of the following is true for a test bench? We discuss test bench, just a basic things. Okay. Uh, in that only I'm just asking. Once we go to depth, we can discuss again interview questions. Okay. Tell. Which of the following
Ma'am, we can't use always procedural block in test bench, ma'am.
is that true? We are not using always in the test bench. We didn't use any time.
It's initial block, no, ma'am.
We are generating clock using always block, and also for demultiplexer or multiplexer we have generated 16 combination of inputs using 3 always statements. You didn't remember? Always hash 5, select 1 equal to not select hash 10 equal to select hash 10 select of 1 equal to not select of 1, hash 20 select of 2 equal to not select of 2, generating 16 combinations or 8 combinations.
Yes, ma'am.
Then what is other?
A test bench is executed only once during simulation, ma'am.
Okay. Mm. And a test bench is a synthesized on during synthesize. It's a wrong, and this also wrong. The input ports of the module being tested have to be declared as outputs registers in the test bench. That also wrong, because all outputs declared with a wire and inputs are declared with a reg data type, because we are using the procedural assignments in the test bench to instantiate to declare to assign the input values, right? So it is also wrong. A test bench is executed only once during simulation. That is the correct option, right? Clear? Next question. Which of the following is or false for an initial block? First statement, is it false? It is used to verify whether a given module is synthesizable or not. Is it false?
Initial is non-synthesizable, ma'am.
Mm. It is not telling it is a synthesizable or non-synthesizable. It is used to verify a design. They are telling. It is correct, right? It is used to verify the design only, right?
Okay.
And here wire type variables can be assigned inside the block. We are not using wire type variables in initial block. We are using reg data type. Okay. When you are assigning with some other value, we are using reg. So it is wrong. And the right hand side of the assignments can have both reg and wire data type, net and register data type. So that is also true. So false statement is wire is not used, right? Any doubts?
No, ma'am.
Okay. Last question. Which of the following Verilog constructs are non-synthesizable?
Initial, ma'am.
Initial and
Assign.
assign is non-synthesizable. Can we use in test bench?
No, ma'am. Initial only we can use in test bench.
What about time? What about time?
Time is synthesizable, ma'am.
Time is synthesizable.
No, ma'am.
So
Non-synthesizable.
time also used in only in test benches. It is also not synthesizable. Okay. So these are the topics what we discussed up to now. Okay, up to sequential logic circuit. I think by end of this week we are going to complete Verilog. Okay, only still some LUTs and lookup tables, finite state missions, memories, test bench concept, and generator. These things are remain five concepts. So by end of this weekend, we will complete the Verilog and we'll move to the project. Okay.